Hello, my name is Connor Memory. The date is December 17th, 2020, and this is my semester 1 final for Miss Kroner. So our problem is, what is the force exerted on a passenger traveling at 100 meters per second at the top of a loop with a radius of 14 meters and a car weighing 1,100 kilograms? So I've listed out my variable, three variables I see here in the problem. I have to write down my forces that are occurring on the passengers inside the loop. So we have mass times gravity. We have the normal force, or apparent weight, acting on the passengers. Now we can use the equation normal force plus mass times gravity equals the force centripetal, and the force centripetal is equal to mass times velocity tangent squared over the radius. So we can substitute this in, and this becomes the normal force plus mg equals the mass times the velocity tangent squared over r. And now we can solve for our variable, which is the normal force. So we can minus the mass times gravity on both sides, leaving us with normal force equals mass times velocity tangent squared over r minus mass times gravity. And now with this equation, now we can substitute in our numbers. So now we have normal force equals the mass, which is 1,100 kilograms, over the velocity tangent, which is 100 meters per second squared, over the radius of 14 meters, minus the mass, which is, again, 1,100 kilograms, times the gravity, which in this case will round up to 10 meters per second squared, put brackets around that. This comes out to be 785,714.3 newtons, because kilograms times meters per second squared is 1 newton, minus 11,000 newtons. And in total, this comes out to be 784,614.3 newtons in total exerted on the passengers.